Hi everyone, my name's Michael. I'm a ranger with Parks Victoria. Now, today I'm going to talk about the LoRaWAN enabled remote monitoring of feral cat traps. This is a project that Erin Nash has set up, and she's would have loved to have presented on it today, but unfortunately she's not able to. She's away. So we acknowledge the traditional owners of the country in which this project has been carried out, the Gadibanoo people of the Maar Nation and the Wadawurrung people. I know this audience needs no convincing about the significant threat that feral cats are to the biodiversity of Otways. So both Parks Victoria's own internal research and academic research since has highlighted the surprising density of feral cats in the Otways, particularly in habitats unfavoured by red foxes like wet forests and cool temperate rainforests, but also in areas where fox baiting has suppressed red fox populations and has led to a mesopredator release. Part of the issue is that we don't have many tools readily available for feral cat control in Victoria. We can use cage trapping on public land in Victoria, but cage trapping is labour intensive and expensive. So the big question is, can we innovate to improve efficiency and efficacy, particularly at the scale of threatened species? There is landscape scale tools available to us, but at this stage, cage trapping is really the only one that's potentially available. So one way to reduce the labour intensity of trapping programs is to use technologies to help you avoid wasted visits to trap sites. Other feral cat trapping programs around Australia have been using trap alert systems for the past few years to remotely monitor trap status. But these systems in well-known programs such as on Kangaroo Island and in the arid recovery are quite large-scale control programs, and so they're often quite expensive. You also need to buy into the proprietary systems, and so that leads to a vendor lock-in, so you can't pick and choose what sort of materials you want to use with it. So Parks Victoria's Otway Arc team partnered with our statewide conservation and science team to review and evaluate alternatives. We identified the LoRaWAN, which stands for Long Range Wide Area Network, as a promising alternative. So the things we liked about this was it's open source, as just runs on radio protocol like a UHF wave. So it's free and unlicensed. It's got near real-time telemetry, less than a second or a couple of seconds delay. It has good transmission distance, and in testing we got 150 kilometres, but the world record is 1,500 kilometres. It can be used for trap status monitoring, but also other park management and research functions. So you can build a multi-purpose network around the system. It's very low powered, so you have small packs of data. Therefore, you can get a lot of battery life out of your batteries on the traps. And it's got a range of open source tools that are freely available to create the back end of the system. So networks that are created by Parks Victoria can also be shared with partners or even public multi-users. So this diagram is basically showing how it works. So each cage trap is fitted with a reed switch sensor in a waterproof housing. To set the sensor, a magnet is aligned with the reed switches. If a trap closes, the magnets will separate and trigger the sensor to send a message. The sensors are also programmed to send a heartbeat message every 2 hours to basically say, I'm still open or I'm still closed. Sensors send that signal to the gateways, which are those big aerials that you can sort of see. And we've got 2 of them set up out on Blanket Bay Campground and just off Blanket Bay Road. Each gateway has a Telstra SIM card in it and connects to the internet via 4G. So only the gateways need to have 4G reception. The gateway sends the coded data to the LoRaWAN server in the cloud. It's then decoded and sent to the application servers that store and visualize the data. The final image shows the end result, which is what we would see on our laptop each morning when we check it. And that's showing the green equals the trap's still open or the red's closed. You can also see when each trap's closed, giving you additional valuable data. So our aim was to test the LoRaWAN as a tool to remotely monitor trap status within a habitat of type in a range of habitat types in the Otways to better understand its longer-term potential in the Otways and beyond. In doing so, we're trying to answer a few key questions. How does LoRaWAN coverage compare to modelled coverage? How accurate are the sensors' reports of trap status? How much time does LoRaWAN save, and how does that translate into cost savings that can be reinvested back into the programs? And how can networks be further optimized? And what else do we learn about feral cat populations and how to do good feral cat trapping? Whilst we're going to skip a couple of phases of the project in this presentation, we carried out extensive research, developing and testing before we carried out tests in a live trapping environment. For phase 3, we engaged the Conservation Ecology Centre to assist us with trapping and testing equipment for a continuous 6 weeks. The study area we chose was Cape Otway, and there are many qualities that make Cape Otway ideal for this project. It's got an existing Parks Victoria trapping program to build on. It's the headquarters of the Conservation Ecology Centre, so there's good collaboration opportunities. There's well-researched area with existing data available from camera traps, diverse landscapes and vegetation types to test the radio waves. It's got a refuge area identified through the Wild Otways Initiative, and the geography and terrain make it a promising future climate refuge. There's also recent disturbance from a bushfire, which made feral cat control even more pressing in this area. Whilst we had 4 focal areas, including a cluster of traps off Lighthouse Road, the core focus of the project was really the area bounded by the pink lines, which is Refuge Area 10 from the Wild Otways Initiative. This area is only 7 kilometres squared, but contains a diverse assemblage of threatened species, particularly small animals, but also shorebirds. The Lighthouse Road trap was included because we had a good pre-controlled data through cameras deployed under Parks Victoria's deer program. It also gave us the opportunity to answer the questions, can we catch cats in cage traps in the wet forest away from visitor nodes? And the answer is yes, we can. We caught 3 cats here. It's also worth noting that the 7 kilometres squared in our study area is significantly smaller than the study area of projects that have previously evaluated the efficacy of cage trapping for feral cats. So how accurate are the sensors' reports of trap status? No sensor ever reported it was open when it was in fact closed, and that's the most important error to avoid, or vice versa. The 100% accuracy threshold was met, and we proceeded to remotely monitoring traps which had sensors. There is a bit of complexity with missed messages, so when the trap status updates go out, they go out every 2 hours, so there's the chance that we might miss an update, and then you've got to wait for another 2 hours for that update to come, or go out and manually check the trap. So a solution to that was moving the traps just a few metres closer to the road, and that solved the issue with some of the missed messages. We're also trying to reprogram the firmware to send those messages at more frequent intervals, which is a bit of a trade-off with battery life. So this diagram's just a bit of a visualisation of the results over the 6 weeks. It shows the trap status and contents of over the program. Traps are listed on the y-axis and dates of trap checks on the x-axis. The order of traps on the y-axis are from the shortest distance of service at the bottom to the furthest away at the top. Each cell represents a trap check. If the cell is white, then it was open. If a cell is light grey, it was closed but empty. If it's dark grey and has an A in it, it contained a non-target animal such as a long-nosed bandicoot, potteroo, bushrat, swamp rat bird. We caught a few of those. If it's black and has a cat symbol, we caught a cat. The gaps where there are no cells are where there was no trap set because we retired some traps and introduced others as the program progressed. There are a few key results we want to pull out of this. So the best way to understand the impact of being able to remotely monitor traps is to look at this vertically. So of the 23 days the traps were active, there were 8 days where all traps were open. There was no need to visit the site at all. So that transfers into a big labour saving. Those people can then go and do something else with their day. There are also many days where there are significantly fewer traps needed to be physically visited. For example, on the 17th and the 24th, only 1 trap was activated, so the staff member could go directly to that trap, check them, then move on with their day. For a few weeks at least, we seemed to be catching cats on Friday nights. And on one Friday, we had 3 cats in traps. So overall, 6 of the 8 cats caught in this program were caught on a Thursday night or early Friday morning. So we're unsure if this is a real phenomenon or just chance. Now, if we look at the trap activity horizontally, we can learn a bit about particular traps and groups of traps. So if you look at these ones, were inactive or fairly low activity over the first part of the trapping program. So we could decide to move these traps to other locations. Other traps had lots of activity, and we had 2 traps that caught multiple cats. So we've used this information to determine which traps to leave out in the landscape to help us give us the best chance of capturing cats. Some parts of the landscape will have higher probability of success than others, and identifying those areas is key to improving the efficiency and cost effectiveness of cat trapping. One of the most interesting findings was that on 5 of the 8 occasions we caught a cat, this was preceded by an off-target animal capture the day before. And often those were bush rats or swamp rats. It's likely that the smell left from the night before brings in the cats. So this raises some practical and ethical questions, particularly in the context of AI, which in future will allow us to avoid off-target captures. So these results suggest that you may not want to totally avoid all off-target captures, but would it be morally permissible to program AI to still capture native prey species if that helped you capture a cat? We're also confident that around half the cats we caught and removed were cats that appeared on monitoring cameras prior to commencing feral cat control. On the far left is a tabby cat caught on one of the CEC's monitoring cameras within the Forest Fire Management's mulched area off Blanket Bay Road in 2025. By matching the markings, we're fairly confident we caught this particular cat in the first week of our program, 3 months after the camera trap image was taken and approximately 2 kilometres away. This cat was captured in the culvert underneath the Blanket Bay campground. So the total trap nights were 299 over 6 weeks, and we removed 8 cats, which is 2.7 cats per 100 trap nights, which is slightly higher than the average for cage trapping. Without the sensors, the total number of trap visits would have been 379, and with the sensors, 123. So you can see there's a big labour saving. So using the sensors meant that the average number of physical trap visits associated with the cat capture dropped from 47 to 15. And so those additional savings can then be put back into the program, either expanding it or doing other things with the staff's time during the day. The program's sort of continuing, so we left a smaller network of traps locked in, open in the landscape. So after 1 month, we checked the cameras and could see that there was at least 1 black cat that eluded the CEC in the final week. So Peter Checo from Parks Victoria opened this trap on the 28th of July. On the first night, a black pregnant female was caught, which looked like one of the cats on the camera. On the second night, a second black cat, which also looked like the cat on the camera, was caught in the same trap. Whilst we want to be cautious in interpreting what this means, it seems promising that we can successfully detect and target cats within this landscape. There's a few outstanding questions, particularly around immigration rate and how long before feral cat populations return to pre-control levels, and how can LoRaWAN be used in tall wet forests of the Otways. LoRaWAN coverage can be patchy in steep forested terrain, so when we tried to locate a gateway under the tall timber, we found the radio signal struggled to propagate very far. Future directions for the program. So we've left a network of traps out based on what we have learnt about which trap locations are most productive. We're going to continue to monitor feral cat population through traps, but interested in using more precise methods such as genetics. We're aiming to add a third gateway on Cape Otway to provide coverage to Crayfish Bay and potentially further west. And also we're also hoping to start up a similar program in the Eastern Otways. Parks Victoria's Gary Word Arc and the French Island Feral Cat Eradication Program will both have LoRaWAN networks established in the purpose of trap status monitoring in the next few months. And in Gary Word, Deaker Comms are helping us to mount gateways to some of their existing comms facilities and also testing solutions, mobile solutions with the white box trailers that you might see at a bushfire. So we're also working with our IT department to push telemetry into Parks Victoria's Edgery-based apps used for trapping, and we want to work towards further automations for feral cat trapping, such as automated lures, integrating AI, using an AI model that Parks Victoria is currently developing for Victorian fauna, and we will release that soon for others to use for free. Also integrating trap actuators so that traps can be controlled remotely to be opened and closed. And that's the end of my presentation. A heap of people have been involved in this. It's a really exciting project to get involved. There's just a list of people up there that I'd like to say thanks to, but also really want to acknowledge Erin for her work in this project and sort of, yeah, getting it up and running and really sort of instilling the passion into everyone that's been involved. So thank you.
One quick question for Michael. Try and wait for the mics. There's one just up here. Thanks. My recollection too, by the way, is when we did that work with Matt Reese, that at least 50% of the cats are purely black. So good luck with that.
Yeah, there's a good percentage.
I believe this program was featured on Landline not long ago. Am I correct in that?
I don't know if it was this exact one. There's been a few that have been using remote technologies, so I'm not sure whether this one. I don't think it was this one.
My question is, were any of the cats chipped that you caught? So in other words, were they domestic pets out on a hunting trip?
No, most of the cats we caught sort of had that feral aspect about them, so much bigger, a bit wilder looking than
the waste panther, in other words.
Yeah, yes, yeah, and predominantly black ones. We get a good percentage of big black ones, which is probably leads to the rumor about the panthers. Yeah,
more so than tabbies.
Yeah, probably more. Yeah.
Thanks, Michael. I think the one on Landline was the Bush Heritage developed one that closes. Yeah.